In this question, we're told that there are only 3 red counters and 5 yellow counters in a bag. We're told that Jude takes at random 3 counters from the bag, and we need to work out the probability that he takes exactly 1 red counter. Now we can draw a tree diagram to help us solve this problem. Now we're going to start with the first tree. We have 2 branches, yellow and red, because there are only red counters and yellow counters in the bag. We need to work out the probability that he takes a red counter on his first go, or a yellow counter on his first go. Now there are 3 red counters and 5 yellow counters in the bag, which means that there are a total of 8 counters. Now since there are 5 yellow counters in the bag, the probability that he chooses the yellow counter is equal to 5 out of 8. And applying the same logic, we can say that the probability of choosing a red counter is equal to 3 out of 8. But now these probabilities only apply for the first time that he chooses a counter. We know that Jude takes 3 counters from the bag, and so each time he takes a counter, the number of counters in the bag decreases by 1. Let's say that Jude takes a yellow counter on his first go. We'll have to have new probabilities that he chooses a yellow or red counter on his second go, and so this part of the tree represents the second time that he picks out a counter. Now this is assuming that he takes a yellow counter on the first go. Now if there were 5 yellow counters in the bag to begin with, and he takes 1 yellow counter, that means there are 4 yellow counters left, out of a new total of 7. And so the probability of picking a yellow counter the second time is 4 out of 7. And if he takes a yellow counter the first time, the number of red counters doesn't change, and so the probability of taking a red counter the second time would be equal to 3 out of 7. Now if he takes a yellow counter on the first and second goes, that means we only have 3 yellow counters left. And on the third time he picks, he'll have 6 counters left in total, because there were 8 to begin with, and he's already taken 2. And so the probability of taking a yellow counter the third time would be equal to 3 out of 6. Now the number of red counters still hasn't changed, because he's only taken yellow counters. And so the probability of taking a red counter on the third go would be equal to 3 out of the new total of 6. Now let's imagine that he chooses yellow and then red, and so we need to find out the new probabilities for the third go. Now we found that if he takes a yellow counter the first time, the probability that he takes a red counter the second time would be equal to 3 out of 7. No matter what we pick in the first 2 goes, when it comes to our third go, we'll always have 6 counters left in the bag, and so all of these probabilities for the third go will have a denominator of 6. Now this part of the tree looks at what happens when we take a yellow on the first go and a red on the second go. That means that 1 yellow has been taken from the bag and 1 red has been taken from the bag. So if we started with 5 yellow counters and 1 was taken, we'll have 4 yellow counters left out of a total of 6. And likewise, if we started with 3 red counters and 1 was taken, we'd have 2 red counters out of a total of 6. And so we've completed the first half of our tree diagram, which is what happens when we take a yellow on our first go. Now let's consider what happens when we take red on our first go, and it's the same principles all over again. If we take a red counter on our first go, well now regardless of what colour we've picked, we've already taken 1 counter from the bag, and so our new total for this part of the diagram will have a denominator of 7, because there'll be 7 counters left in the bag on our second go. Now if we take a red the first time, that means the yellows are untouched, and so we still have 5 yellow counters left in the bag out of a total of 7. As for the red counters, if we've already taken 1 and there were 3 to begin with, that means there are 2 left out of a total of 7. Now let's consider what happens when we take a red on the first go and a yellow on the second go. If we've taken a red and then a yellow, that means 2 counters have already been taken from the bag, and so we'll have a total of 6. Now we've taken 1 red and 1 yellow. If 1 yellow was taken and we started with 5 yellow counters, that means the probability of taking a yellow on the third go would be equal to 4 out of 6. And if 1 red has been taken and we've started with 3 red counters, the probability of picking red on the third go would be equal to 2 out of 6. And finally, we're in the last part of our diagram, and we need to consider what happens when he takes red the first time and red the second time. We know that since this is the third go, 2 counters have already been taken, and so there'll be 6 counters left in the bag, and we'll have a denominator of 6. If he's taken red and then red, that means the number of yellow counters in the bag is unchanged, and so we still have 5 yellow counters left, out of a new total of 6. And finally, if we've taken a red counter and then a red counter, that means 2 red counters have already been taken, and we started off with 3, and so there's 1 red counter left. And so if we take red the first time and red the second time, the probability of taking red the third time would be equal to 1 out of 6. And so we now have a fully complete tree diagram which represents the first time he takes a counter, the second time he takes a counter, and the third time he takes a counter. And we can use this diagram in order to help us work out the probability that he takes exactly 1 red counter. Let's consider what it means for Jude to have taken exactly 1 red counter. If he takes exactly 1 red counter, that means he can only have picked red 1 time. And so the different combinations for that would be picking red first and then yellow, or picking yellow first and then yellow, or picking yellow first and then red. We'll start with the probability of taking red, then yellow, and so we can follow the probabilities on our diagram. Red, then yellow would be 3 over 8 multiplied by 5 over 7 multiplied by 4 over 6. Now if we have an OR, that means we add the probabilities together. And so we'll add this probability to the probability of taking yellow, and then add the probability of taking yellow, red. Now let's find the probability of yellow, red. Now following our tree diagram, we start with yellow, then red, and then yellow again. And so we'll have 5 over 8 multiplied by 3 over 7 multiplied by 4 over 6. And finally, we have the probability of taking yellow, red. And so to follow yellow, red on our diagram, we'll do 5 over 8 multiplied by 4 over 7 multiplied by 3 over 6. Well, now let's simplify. 3 over 8 multiplied by 5 over 7 multiplied by 4 over 6 is equal to 60 out of 336. 5 eighths multiplied by 3 sevenths multiplied by 4 over 6 is also equal to 60 over 336. And 5 over 8 times 4 over 7 times 3 over 6 is also equal to 60 over 336. And so adding these 3 fractions together, well, they have the same denominator, so we only need to worry about adding the numerators. 60 plus 60 plus 60 is equal to 180. And so 60 over 336 plus 60 over 336 plus 60 over 336 would be equal to 180 over 336. And so we've now found that the probability that he takes exactly 1 red counter is equal to 180 over 336. Now this question is worth 4 marks. We get the first mark for our diagram with all of the correct probabilities. We get the second mark for finding the probability of red, yellow, the probability of yellow, red, and the probability of yellow, red. We get the third mark for a process to add these 3 probabilities together. And we get the fourth and final mark for the correct answer that the probability that he takes exactly 1 red counter is equal to 180 over 336, allowing us to get the full 4 marks needed in this question.